Today I have a special topic I want to cover, and that's understanding the server-client boundary. And what I mean by that is understanding where the server starts, where it ends, and where the client starts and where it ends, and where the overlap is. And at the end of this video, you should understand some common pitfalls you might see and how to avoid them, understanding where you can access, for example, the window object and the process, and where you can't, and how to create server and client-only code that runs only on the server or the client respectively. And yeah, that's the point of this video, and without further ado, let's just jump into it. So the first thing I want to do is I want to show you how you usually end up in the situation where you are scratching your head and not understanding what's going on. So for example, let's go to the root tsx file, and this is the file that renders your layout. So for example, I'm using the base tag by Forge42, and what we're gonna do here is we export the layout component. So this is a special kind of component in React Router version 7. The component itself is not really that important, but understanding how something works and why your code is gonna fail or why it's not gonna fail is important. So I want to show you a contrived example of how you might end up calling client-only or server-only code in something that's not supposed to run those kinds of code snippets. So for example, in the root here, so what's important to know is that in React Router version 7, every component is considered a client and server component. So for example, every default export is considered both server and client safe. So that means whenever the server runs this code and the client runs this code, it's gonna execute without any problems. Now let's imagine this scenario. So I'm not gonna install anything into this project, but let's create a dummy function and I'm gonna call it sentry. And what you're gonna imagine is that I'm gonna do API key, and that's a string, and let's say this sentry function is gonna set the window.sentry is equal to API key. And this seems very stupid, but imagine if this sentry function, instead of being just this, is actually initializing sentry or anything else. This is not how sentry gets initialized, but this can be anything, and let's say it calls the window.sentry. If you want to initialize it and you do something like this, sentry, and you call it, and then you do something like, I don't know, API key. If I save this and I run this, what do you think is gonna happen? Well, if you thought you're gonna get window is not defined, you were right. And why is this the case? So if I actually go to the browser, I want to show you something. So if I go back to the editor one more time, and if we look at all of this code, so as I said, this needs to be both safe on the server and on the client. So if you look at the canvas I'm gonna use, and if I draw this circle, and this will be our server. So I'm gonna color it green, I'm gonna make it like this, and this is our server, and then we have our client here. So the client is gonna be client. I'm gonna make this a different color so we can differentiate between the two. All right, so, and I'm gonna make this overlap a bit bigger so it's easier to understand. So all of the React code that goes into here must be safe for both environments. And in our example, because we're calling window.something, this is not available on the server. This is a client-only thing that's available in the browser. And stuff like document or any browser API that is in the browser, so on the client, is not accessible on the server. And this works both ways. So if we have server-only stuff like process anything, so process.environment, for example, if this server-only API gets called on the client, it's gonna not work. And the reason behind this is because the server has the access to the current running process and the client has access to the current browser window. So that's the reason why window works on the browser, but it doesn't work on the server. And it's the same reason why process works in the server and it doesn't in the browser. So each of these components that is safe for both needs to fill this zone here and not use any of the server APIs or the client APIs. So if you go back to the editor, so the reason this fails is, the file is called root.tsx. And if we look at this drawing, and if I say that this is the root.tsx module, so a module is a file with all of its content, in this case. So why is this root.tsx not safe? So the reason behind this is because we do window.sentry in the code, this belongs to the client only, and the reason it fails is because the server does not have access to the window object. And if we go back to the editor, if we replace this with something like const object is equal to API key, okay, this is maybe a bad name, let's call it a string. And if I save this, and if I scroll back here, you can see that it works now. So imagine this scenario. You have everything here is safe, but you don't want to hard code the API key. You want to pass in the API key that comes from either the process or the window. So let's imagine this. I don't want to hard code this. I want to access it from the actual environment, but I want it to work both on the server and on the client. So what is the way to do this? So one of the ways to do this is to guard the access to the window.environment or window.anything with type of window is not undefined. So what is this gonna do? On the server, because the window object itself is undefined, you're gonna do this check, and then if the window exists, you're gonna do something like node environment via window.environment.node environment. And if the window is undefined, that means the process is defined. So this is a really simple, so this is complaining because our biome settings don't allow you to access process environment. But if I do ignore, you're gonna see this is valid code and this doesn't complain. So this type of check is gonna be your best friend when you're doing something that is required to be like a poly environment that works in both places. And the reason this works is because in the browser, the window is gonna be defined. So this will go into the first condition, and on the server it's gonna be undefined, so it's gonna go into the second condition. And this guard is usually how you get around environment variables or some simple things like that. But what you need to be aware of is that this can also lead to hydration mismatches. And how is that the case? So if I do something like if type of window is equal or different than undefined, so if I do this and then return a div, and otherwise I return a paragraph with something. So on the server, because this is true, so on the server, because this is false, it's gonna go into the else here, and I don't really need the else, I can just return this to make it more clear. So this will be your server return, and this will be your client return. So if you don't already see the problem here, the server is gonna render a p tag, the client is gonna render a div tag, and you're gonna cause a hydration mismatch because it doesn't match the content that's on the server to the content that's on the client. And you might wonder, how do you get around this? And I'm gonna show you in a minute, but I want to explain a different concept that's really important to understand before we go into this one. And that is the concept of side effects. So if you already noticed, this now works. And if I actually open up the browser and then I refresh this, you can see that it loads up the page. But what's important to understand in the editor is, what if I do this? So for example, instead of doing this, I'm gonna call I'm gonna pass a callback function that's gonna return window.environment.node-environment. And this is gonna be something like this, and it's gonna return a string. And then I'm gonna save this, and I'm gonna go to the browser. And if I refresh this, you can see the page still loads and it works fine. And if I go back to the file, you can see that I call, or rather I don't call it, but I pass it as a callback function, and I directly call window.environment here, but it works. So why is that? So the reason behind this is because this, when called, is considered a side effect. So what is a side effect? A side effect is something that runs whenever the module gets evaluated. So, for example, here, because we call the sentry function directly in the file, so we don't really, for example, call it inside of the component, or we don't call it inside of our loader here, or anything like that. We call it directly on the root of the file. This is considered a side effect. And the most famous side effect that I can think of is something like this. So const db is equal to new prisma client, and then you do something like export db. So if you had a file that was db.ts that had these two lines here, so this would be considered a side effect file, because what it does is, and let's say import prisma client from prisma client. So this is your db file. And why is this considered a side effect file? Because you import the prisma client from a package, and this can be 1 million different things, and then you instantiate this class. So you call this, and this is gonna do something in the background. So for example, in our case, initialize the database client, and then you export it from the file. And even if you didn't export it, if it was only like this, you would still consider this a side effect, because it triggers something and does something behind the scenes. And even if this was something like, I don't know, you had your own function. So for example, function test, and inside of test you did something, and then later on the file did this would still be considered a side effect export, or rather a side effect file. And the reason that I want you to understand side effect files is because that really is important if you're doing anything with server and client files, because a lot of libraries or third-party libraries, whenever you instantiate them, they do something behind the scene. And what you can run into oftentimes is, for example, if you have this, the library itself is gonna try to do something like window.sentry is equal to API key. And if I save this, you see that I again get the error here, window is not defined. And the reason behind this is because I call this as a side effect, and because this module gets bundled on both the server and the client, on the client this would work just fine, but because this gets called on the server, it's gonna try to set something on the window object and it's gonna fail. So that is the most important thing to understand when it comes to side effect exports or side effect files. So side effect exports are literally when you export something from a file and that file triggers a side effect, and side effect files are files that trigger side effect. Why it's important to understand how this works is because you're gonna end up in a situation where you import something from a third-party library, you call it in this way, or maybe it's something like this where you have it's more like this, so API key is like this, and whenever you do this, it's on the top of the file. It's gonna crash because this will get run on both the server and the client. So you're gonna end up in a situation where it crashes on the server or on the client. It depends on the library. So for example, if it's a server library, it might try to set something on the process and then fail because of that, or call some side or call some server API that's not available on the client, and vice versa. So if it's a client library, it might set something on the window or try to access the document to augment something or something like that, and it fails. So What's important to understand is whenever you have to define something in the root of the file and run it as a side effect, you need to guard with type of window is different than undefined. Use the window object, otherwise use the process. And this will be your best friend when it comes to side effects. Now, let's say you have a client-only library that you just want to run on the client, and maybe this is something like Google Analytics, or I don't know, maybe Postdog or something like that, or not, maybe even, I don't know, something 3JS related, whatever, and it requires the window object like this, but you can't really run it as a side effect because it's gonna crash your server. So what you can do is, because on the server, useEffects don't get triggered. So what does that mean? So if I call Sentry here, and I do window.environment.sentry API key, and if I save this, if I scroll down, you can see the server restarted, and this works fine now. And if I change this again to be something like a string, and then I delete this, and I say Sentry API key, and sorry for using Sentry as an example. Hopefully it's not confusing, but I just want to demonstrate the third library use case. And if I save this, and if I go back to the browser, and then I refresh this, you're gonna see that it works again. So the reason it works again is if I switch back to the editor here, if I look at the useEffect, and I see that the Sentry is called here, and the reason this works is because useEffects don't get triggered on the server. So the server renders the component here, but it doesn't trigger the useEffects. And this only gets triggered once the application is hydrated. And a common utility you might see in the wild, or you may be imported from something like Remix utils, is, for example, this is client. And then what you're gonna do is you're gonna set it to false. And then inside of here, you're gonna set the isClient to true. And then, for example, you're gonna render something conditionally, where here you're gonna say isClient set to true, render a div with something like Sentry root, otherwise render nothing. And you can see I'm conditionally rendering this. And if I switch back to the browser, and if I open up the console, and refresh this, you can see that we have no hydration mismatches. And if I go back to the editor, the reason for this is because this doesn't get set to true on the server. This only gets set after the page is hydrated. This is gonna render the div after the initial hydration check. And if I switch back to the browser, let me just show you how this works. So first of all, the server renders your content. So this is content that's on the server. And then it gets sent to the client. So the client then renders its own content. So client content. And once this is rendered, what is React gonna do? It's gonna say, okay, let me check the content from the server. Let me check the content from the client. And I'm gonna do React here. And I'm gonna color these three. React is gonna render these two. And then compare them one to each other. So it's gonna say, okay, is the client content same as the server content? And is the server content same as the client? So this is how the hydration mismatch works. And after this is done, what is gonna happen is React is gonna say, okay, they are identical. Now let me run the effects. So if I go back to the editor, so it already rendered this. It was null on the server, and it was null initially on the client as well. And because both of them were null, it's gonna render identical content. And once the hydration check passes, it's gonna run the effects. And because this effect sets this to true, it's gonna render the div then. So this is how you artificially create a client-only component. All right, now that we understand this concept, so if you've ever seen a utility function, like, or rather a component called ClientOnly that looks something like this, and then it takes like a callback function, and then you do something like this. If you've ever seen this in the wild or any example videos or something like that, this is usually how it works. You can use different approaches. You don't need to use useEffect. You can use, for example, use sync external store. It does the same thing. It's just a cleaner API. But in a nutshell, this is how it works. So it checks if your effect has run, it sets the variable, and then it renders the content. So this is a really nice trick to render client-only components, because you can use the useEffect to switch something on or off and then conditionally render it. And this is like a great pattern to use when you have to render client-only components. And this is the case, for example, if the client tries to do something like document dot something on the root, or it has a side effect that needs to run only on the client, this is the way to do it. And you can also find some more advanced use cases like providing fallbacks to client-only and stuff like that. But usually this is how it works, and this is a neat trick to know because useEffects don't run on the server, so these are safe, and you can do literally window.environment here, and this is gonna work because inside of the useEffect scope you are safe to use these. Alright, so that's another thing that I wanted you to understand. And now that we understand these two concepts, there's a third thing I want to cover. And if I delete all of these examples and I save this, for example, let's say I have a function that needs to be executed in the loader and I don't want it to accidentally end up on the client. What I can do is I can create a .server file. So for example, let's say function.server.ts, and from here, I can export a function that gets run only on the server, and vice versa. So if you want to do something like client only, you can do component.client.tsx, and then you export a component that it belongs only on the client. And this means that it won't get bundled in the server. It's only gonna get bundled on the client and vice versa. So when is this useful? The best examples are if you, for example, let's say you're migrating an old code base and that code base uses some sort of old library, and that library uses, for example, style components. Style components don't run on the server. They try to use the document head and inject styles directly. So whenever you use style components, they're just not gonna work. And you use those components and you can't really migrate off of them. You might want to do something like this. So for example, let's say you create button.client.tsx, and then inside of there you do function button, and let's say you're importing from a third party, and that third party uses a special button with style components. So for example, import special button from third party /button, and this special button when rendered uses style components. So you just do return special button, and then you just import that button inside of, for example, this file, and then you run it here. And this wouldn't work because this import doesn't exist, so this would crash. And then again, it's in the same file, so it's not the same thing, but I can assure you that this only gets bundled on the client, it's not run on the server, and that's how you get client-only components. Now, sometimes this doesn't work, and I'm not really sure how you end up in the situation where it still ends up running improperly. But what you can do is if this still doesn't work, so if you create a button.client.tsx, you will do all this song and dance, you export this button, and then you import it here. So for example, you would do something like import button from components button, and then you render it here. inside our layout, which is here. So if this doesn't work, you can use the utility I explained earlier. So you do ClientOnly, and then you render the button. And this will 100% work in any case. So in case you end up in this situation, this is something you can use. And that's pretty much it for the client stuff. Now for the server stuff, it's the same thing. So if you want to do something like invoke get environment here. So for example, from the environment.server, I import get client environment. And this will work on the server, so in the loader. And if I call this, it's gonna work. And if I save this, and if I refresh my page in the browser, you can see I get new logs and it all works fine. But if I import this and then I use it on the client, so for example here, it's gonna crash. And why it's gonna crash, it's gonna tell me, hey, you've imported from environment.server, the root tsx file is where you imported it in, and these are the server only code places where you can use it, please remove it. And then you just go back here, you figure out, oh, I've imported it by accident, I used it on client code, and I need to remove it. And if you don't understand how all of this works, so when is it called on the server and when is it called on the client, the best way to think about it is the following. So loader, action, and pretty much nothing else is on the server, and all the other exports are either client only or run on both. So what does this mean? So if I go back to the browser and if I do the following, so if this is your module, so the client has, so if this is your file module, so as we said, a file module, everything that the file exports, and you export the loader and you export the action. So these two things are server only. So this means that they are so if I call this the module, so this module has two things. It has server only stuff, so server only, and what falls into this category is loaders and actions, and all the other stuff is client and server. So what does that mean? So for example, component, links, headers, all of these things run on both the client and the server. So you can see the overlap here, and this is included in both. So how React Router bundles your code is it creates a server bundle and a client bundle. So if we do a client bundle here and we do a server bundle here, so we're gonna say server bundle. So this is your server bundle and this is your client bundle. And how it works is it's gonna take the server only stuff, it's gonna bundle it and include it in the server. So it's gonna say servers, so it's gonna say give me the loader and the action, I'm gonna execute on the server, and then again give me these things. So if I make this smaller, it's gonna say give me these things, and this is the final server bundle. But the client bundle only has these things, so these get sent to the client bundle. And the reason your server bundle can only have stuff in the loaders and the actions is because, first of all, when it's packing the client bundle, it removes the loader and the action. So if I go back to our code, so how the bundler is gonna work, it's gonna clean this, and then it's gonna say, okay, let me see what I removed. Okay, this is the code, so the error boundary, the layout, and the app. It has the links exports, and I'm gonna remove everything that's not used anymore. So it's gonna remove the get hints, and this is the file it's gonna pack and send to the client. And obviously this is now complaining, but TypeScript doesn't really know what we're talking about here. And the reason this works is because if, for example, we had an import here from, so if we import get client environment from environment server, if this is left in the bundle, this is how React Router knows you've used server code inside of client code. and vice versa if you've used client code inside of the server code. And this is important to understand because this is how the bundler is gonna know if you're messing it up or not, and this determines what gets bundled. So if you get a warning that you're using server code instead of client code, this is usually the reason. And one final thing I want to explain before I leave you off is don't use barrel files. And if you don't know what barrel files are, so for example, let's say we have services here, and the services folder has client hints. And what barrel files are index.ts, and then I export everything from client hints. And why you would do this is then you would end up with something like this here. So for example, import from, and then I do services. And I don't have to do something like services client hints. I can just import directly client stuff from services. So this nicely couples all the code and bundles it together and gives it to you, and then you have all of these utility functions coming from the same place. And this is maybe not useful for services, but if you did the same thing for utilities, you would get all the utilities functions coming from the same place. So this sounds like a great idea. Why wouldn't I do this? Well, the first thing that you can end up doing with this is creating circular dependencies. So that's the first thing. The second thing is you can blow up your bundle size. So for example, if instead of bundling only this function imported directly from client hints, what you would end up doing is bundling all the functions from all the files into every file. And the reason that usually happens is because the bundler can figure out precisely what's used and what's not. But the worst out of all of the things is if you have an index file that imports and exports a lot of stuff. So in this example here, it's pretty simple. It only exports one file. But if it exported 50 files, and any of these 50 files had any side effects going on, what this would cause is you would get a very subtle bug where your client and server, depending on what went wrong, doesn't work. It doesn't fail initially, but the UI usually fails like after some of the files are loaded. You have no idea what's going on and what's causing you to get like ultra random errors, and you have no idea what's causing them. And the reason is because, for example, here you did something like export db from db, and this file itself had a side effect export that initialized the database, and you exported it from this fancy barrel file. And this fancy barrel file tries to initialize the database and then tries to give you 5 utilities that you use. And this causes your code base to explode, and you have no idea why, because it doesn't come from a .server file. Even if it has the .server file, because you use the index.ts, you kill the convention. So you literally kill your code base silently. You have no idea what's going on. And this is like one of the worst patterns you can use. I've personally loved this and used it, and then I realized what the side effects are and what the downsides are. And when I said side effects, it was pun intended. And this is one of the biggest enemies of your code bases, so please don't use barrel files. All right. So that's the last thing I wanted to cover. So please don't use barrel files. You're gonna shoot yourself in the foot, and you're gonna cry about it, and you're not gonna be happy. So now you understand how the server and the client boundary works. And what's important to understand is that you have 2 different environments that run the code. So even, for example, what can also happen in some rare cases is, for example, your server uses a node to import stuff, and then your client uses ECMAScript modules, and sometimes they differ. Sometimes the server ends up using CJS and the other one uses ECMAScript modules, and you can end up in situations where the server tries to import a package, it fails, but on the client it would work. So for example, let's do something like import for example, date picker from React date picker. And you use this library, you want the date picker, and then you, for example, want to render it here, and you're all happy. You save this code, you can see there's nothing wrong with it. You save it and it blows up and it fails. So the reason this happens is sometimes node resolutions work differently, and if your server has a different node resolution than your client, it can cause node to get confused about the default export. So sometimes you would have to do a hack like date picker component is equal to, and then you would have to do date picker.default, so type of this is different than undefined, and you would do this whole song and dance, and then you would just render it here. So this is not really your fault. It's not React router's fault. It's just the fault of the fact that sometimes some third-party libraries are not bundled correctly. The package JSON mistakenly reads the default incorrectly and tries to use it, and then it fails. So something to know is that sometimes you could have problems with older libraries like this. So that's also something important to know about. And I think that's the last of the tips I have today. I hope you managed to follow along and I wasn't too complex about this. I kind of tried to condense everything I know about server and client into one video so you can kind of help yourself code easier. And one more thing before we go is, for example, the handle export. So if you try to recap everything we learned, so for example, if you wanted to do something like client and server safe. So how would you do this? I'm gonna give you 5 to 10 seconds to think about it. Alright, so if you thought about doing something like this, it's correct. If you thought about doing something like this, it's correct. And if you thought about doing something like this, it's not gonna be correct. And if we recap once again, if you have side effects, they're not gonna run. If you have client or server only components or functions, they're not gonna run in different environments, so you need to be careful about that. That is both a blessing and a curse. Code is really reusable if it's used across both without any issues, and there are a lot of APIs that work across both, so this is not really a common case. Usually you're gonna have the problem around window.something or document.something and stuff like that, but if you use browser APIs inside of useEffects here, so for example, if you do useEffect, I don't know, document dot, I don't know, body dot scroll to, for example, and I forgot the R, this would work. But what wouldn't work is if, for example, if you had it outside of the useEffect, or if you had it, for example, here, or if you did something like const element is equal to document get element by ID, this wouldn't work either because this is not defined on the server. And yeah, those are like kind of the most common types of situations you're gonna run into. How to go around them, how to fix them, avoid them, depends on the use case really, but this is all of the tips I have for you, and I really hope this helps you understand the client and the server boundary and how to get across it, because the hardest thing to do is really to get across it, but once you're over it, you understand how it works. It's really easy to not run into these issues, and then you really understand, okay, if I do this, it's gonna cause an issue. Okay, this third-party library uses document.something, this is why it doesn't work. Okay, I get window.undefined. I have something that's calling the window object, even if it's not my code. And yeah, that's pretty much it. I hope you enjoyed this one. It's kind of an in-depth dive, but I really enjoyed making these because you can learn a lot from them, and it kind of explains all of my hair pulling for the last like 2 years in like 10, 15, 20 minutes. And that's pretty much it. Thank you for watching and see you in the next one. Bye!